Hi, so we are going to continue to talk about linked list, and specifically we're going to talk about the find data method and the contains method. Okay, so in linked list, I think we talk about the add method. So another very common method is to, after you're adding some data, you want to find it, right? So for the find method, basically we have, find, and then the parameter will be the data that we're looking for. What it returns is that if the data exists in the list, it should just return the data itself. Otherwise, if the data is not in the list, there are multiple ways of doing this. Sometimes people like to return none, but what we'll do in our version is that it will actually raise a key error to indicate that the data is not in the list. Okay, and this really should be fairly straightforward given what we already written. So I'm going to ask you to pause the video and actually try to implement this method yourself. Right, so assuming that you have done that, and here is the way I'm going to write it. And so in terms of find, I'm just going to iterate through all the data in the list, in myself, the linked list. And if the piece of data that's in the list is the data we're looking for, then we'll just return. And if we go through the entire list without coming into the return here, that means the data doesn't exist. And in that case, we're going to raise a key error. Okay. And now, again, the reason this is so simple is that, first we took advantage of the fact that we implemented dunder iter, and we don't have to worry about following the next pointer and that sort of thing. So that's good. And then another thing I want to say is the reason we're using the key error is because key error is already defined. It's kind of a standard way of indicating that the data being looked up is not in a data structure. So this is used, for example, in the dictionary, Python's built-in dict, that if the key, when you're trying to look up a key and that key doesn't exist in the dictionary, it actually raises the key error. Okay, so having implemented the find, we really ought to test it. And so for this testing, we are going to do something a little more rigorous than what we have done so far. So I am actually going to have a list of data that we are going to insert into our linked list. So I allocate that list of data here. I have a linked list and then I actually will add everything in this data list into our linked list. And then I'm going to go through all the data again, all those numbers again, and I'm going to look them up in our linked list. I'm going to remember it. Maybe I'll call it actual. So what we actually find, and I'm going to assert that it's equal, that it's actually equal to I, right? I is the data we're looking up. Okay. So this ensures that we look for every single piece of data, and all of them should be in our linked list. Okay, so we run it, and good. So that works. Okay. All right. So also, so we just look up data that we know are in the list. We should also test the fact that when we're looking for something that's not in our list, that it should raise the key error. Now, however, so let's say, I allocate an empty linked list and I'm finding something that is not there. So it should raise the key error, right? So, but if we run the test, we know it's going to raise key error, but that's what we expect, right? But the way it runs right now is any sort of exception that is raised is considered a failure. However, raising an exception in this case is considered success. So how do we actually assert that when an exception is raised, it's a success? Well, very helpfully, the unit test framework has this thing called, well, we have to start with the with assert raise. Okay, and I want to make sure it raises a key error. Okay, and the with block, you probably should have known it, at least from the file IO, that this creates a block of code. Okay, and what this with self assert raise does is it makes sure either during the execution of this block of code or basically by the end of this block of code that is being executed inside the with, a key error is raised. So if it's raised, then it's considered the assertion is true and the assertion is good. However, if no key error is raised in this block of code, then the assertion fails. So this one should raise key error, as we saw, and it's considered a success. So that's great, and we will also actually just also make sure another case that's also true. I mean, right now the linked list is an empty list, so we'll insert something into the empty list, but we'll look for a number that is not one of the numbers that we inserted. Let's say we look for 666, and then with self again assert, we're going to make sure that this block of code raises a key error. So if we run the test, and yes, it passes both tests. Okay. All right. So the next thing we want to do that is related to find is actually, so if you look at a find data, it just returns data. So that's, I mean, we already know what we're looking for. So why we bother just returning the weird thing that we're looking for? So the question that find is really trying to answer is that whether data exists inside the linked list. And when we're trying to check if something exists in a particular data structure, there is a standard dunder contains method that if you implement it, it does exactly that. So in that case, I'm going to ask you to pause the video and actually implement the dunder contains data method. What it should do is that it returns true if data is in the linked list and false otherwise. Now you should be able to keep this very, very simple, and make sure once you're done, test it. Okay, assuming you have done that, I am actually going to do this very quickly because it should be very simple. So I can basically use find data, right? And now if find doesn't raise an exception, then we found it. So, and if it raises an exception, then the data is not in the list. So I'm going to put this in the try block. If find doesn't raise any exception, I'm going to return true because that data is in the list. Otherwise, if it raises a key error, we'll return false. Okay, and of course it's not find, it's self.find. Okay, so that's that. And to test it, we can just test it very similarly to find. I'm going to have a list of data here. I'm going to insert all that data into our linked list, and for every single one of those, I'm going to make sure contain would say contains would contain is true. So here is another thing that I'm going to use assert true, that I is in our linked list. And so you should know that when you do in kind of explicitly call ll underscore contains. So I can actually also, why don't I also do that? ll contains. So yeah, both ll dunder contains I and I in ll, those are exactly the same. And obviously, usually we write I in ll because that's more readable. Okay, so let's run this. And yes, it continues to work. And one more thing, so we want to make sure that if an item is not in the list, we wanted to return false. So we're not gonna write a separate test. I'm gonna just assert false here, that let's say 66 is not in the linked list. So let's run this, and yes, it's that's also correct.